Okay, so our group is looking at car user interfaces. We're group 23, myself, Josh Henry, Ace Riverman, Carson Tobias, and Sander Malmquist. Our group was interested in car user interfaces and how the consumer interacts with them while driving. We thought it was a fascinating field to study and something we could all learn from. Something that interested us right off the bat was just seeing that a lot of car user interfaces kind of lag behind the current trends. A lot of luxury car brands and new car brands don't have computer interfaces that match with current technology. So because of that lag, we wanted to figure out a way to put our experience and knowledge to work and just see how we could fit the automotive industry into this class and what we could learn and how we could maybe take some steps forward in that industry. We decided to research the effect of interfaces on drivers' focus. The reason why it's important is because car user interfaces are a part of driving in today's world. They let you interact with your car, they let you interact with media, they let you interact with the outside world to some degree. They're not going away anytime soon. They're a valuable tool that are in most modern cars. But when you take away all of the glamour of them, we wanted to see how safe they were to use while driving. So our experiments were aimed at figuring out how distracted will a driver be if they're using an interface in their car, and what interfaces provide the least amount of distraction for a driver. Car user interfaces have the unique problem of being a secondary task. Driving is a far more important task when you're operating a vehicle. Um, so whereas computer use, an app on your smartphone, stuff like that, it would be the primary task. It wouldn't require any special attention. With cars, it's very secondary, which is a safety issue. Interacting with them is more about being able to focus on the road and less about the pleasure and satisfiability of interacting with the interface. It's practicality over design for sure. We needed a way to test how much an interface will affect a driver's ability to operate a vehicle while trying to perform everyday tasks with the interface, and also driving the car with minimum errors, maximum attention, yeah, just the least amount of distraction. So we put together an experiment that we think tests that. We were able to get a hold of a Logitech racing wheel. We ran it with an Assetto Corsa racing game on a laptop computer. We used a short track and a slow car to try to get results as close as possible to the real world, and avoid the idea of it being a racing game and get it closer to actual driving. This helped us avoid the expense and headache of more expensive simulators. Our aim was to create something that would model the real world, but also fit into the scope of this class, fit into our own personal budgets, and be usable by most people quickly so that we could get testing done quickly. We used a view in the game to give the driver the best possible field of view to most accurately model how much that a driver would be able to see as they were using the interface, and we mounted the phone for the test that involved a mounted interface. We mounted the phone in a place that made sense for actual driving.
In order to test the car user interfaces which we selected, we gave each participant 5 tasks to complete on each interface. The first task is to play music using their preferred music app. The second task is to play music using a different app. The third task was to text someone. Fourth task, make a call. Fifth task, navigate to an address. So during each of these tasks, we had the driver driving. We gave them a practice lap around the course, so that way they didn't feel completely new to the course before driving. We had the car user interfaces right next to them, similar as it would be on your dashboard. And so we had them complete laps around the track, and we had one person watching driver errors, one person measuring the time to complete each task, and the last person was recording data in the Excel spreadsheet. We also made sure to keep track of the total time to complete the actual lap. With these 7 metrics, we figured we could get some very useful statistics in order to perform analysis with.
So here we have the drive mode application. It's a very simple, clean UI with large buttons for common functions.
Call.
The voice actually reads out what you click as well, so you don't have to look down. There's 4
Navigation.
simple functions: calling, navigation, You can play music with various apps, and you can text people as well.
Message.
There's also built-in voice controls for all of these. So here we have the Android Auto application. You can see the simple UI on the side, the taskbar with most of your basic functions. You have music, which you can play through multiple different apps. You have the phone, so you can make calls very quickly and conveniently. You have navigation, as well as, while there isn't technically a texting command, you can just use the voice controls built in to text. Here we have Josh, he's doing the racing. We have Ace recording the data. We have Sander doing the timing and counting errors. All right, go.
Alright, so make a phone call to me.
It's 21 seconds. 21.47.
Alright, play music with your preferred music app.
$5.37.
Alright, navigate to Denver.
$14.12.
Head south on 8 Van Dyke and wait.
Okay, send a text message to me that just says, hey.
$17.58.
Let's now move on to the statistical analysis and results of our data collection. So, our data was analyzed using a multi-level linear model to account for dependencies that come from the nested nature of the data. This test showed if there were statistically significant differences between the phone usage methods for each metric that we measured. A post-hoc analysis was also conducted using pairwise t-tests to show where the differences between methods arose, if any were present. For our alpha values, we used 0.05 for all tests. Here you see the graphs that show the means and confidence intervals of each of the tasks that we asked the participants to do. Here you see selecting music with application 1, which would be the user's preferred application. Here you see the graph for sending a text message. Here you see the graph for making a phone call. Here you see the graph for making a music selection using a secondary application. Here you see the graph for navigation. We chose these tasks because they're some of the most common tasks that someone would do while driving a car and using a phone at the same time. As you can see, there does not appear to be much difference in the time it took to do any of these tasks from these graphs. This next slide shows the same type of graphs just for the lap time that it took for the user to complete the course and for the amount of errors that the driver had while they were doing the course. And again, you can see that there's not a lot of difference just visually here. This next slide shows the p-values from the multi-level model that were obtained, and as you can see, For all of these metrics, none of them met the alpha value of less than 0.05. This slide shows the pairwise t-test results that were obtained while doing the post-hoc analysis. And you can see from just taking, for example, this music selection application 1, this shows that there was no statistical difference between not using a driving app and using Android Auto. This shows that there was no statistical difference between not using a driving app and using drive mode. And this shows that there was no statistical difference between using Android Auto and using drive mode. If you go through all of these little graphs or little charts of this data, you can see that none of the p-values ended up being less than our alpha value. So there was no statistical difference between using any of these apps for any of the tasks or metrics that we measured. So now just quickly talk about the statistical results. None of the tasks tested had a p-value below 0.05 when using the multi-level linear model. The differences in time required to complete the task between methods were not statistically significant. The difference between lap time and errors were also not statistically significant when looking at the multi-level linear model. As expected, since the multi-level linear model did not show any differences, post-hoc analysis using pairwise t-tests did not show any statistically significant differences between any of the methods of phone use. So basically, using your phone or using these apps takes pretty much the same amount of time, therefore causing the same amount of distraction to do all of the tests that we had the drivers do.
All right, so some of the limitations of our study. Budget. We couldn't get a lot of the greatest materials or things to use for our study. For example, I have properly simulated driving, so we used a racing game instead of a real driving simulator. We mounted a wheel to a desk and used like a stationary chair. So it was hard to get the best of the best devices and such to get like a truly properly simulated driving. Another limitation was safety, so we couldn't just put someone in a car and ask them to do all these tasks because distracted driving is dangerous, and even with like a closed course, it still wouldn't be safe for the participants, and shouldn't be asked of anyone to put them in danger for this study. And so yeah, simulation is the way to go to have safety. And like I said, without a huge budget, there's only so much you can do to simulate driving. If we had unlimited money, we'd have a whole experience with tilting of the seat and a big simulator with screens all around, and we just had a laptop, a racing wheel, some pedals, and so budget being the root limitation, I think, kind of caused the rest of these besides the safety thing. So yeah, that was the limitations. Some things we would do different. I think we would test more applications than the ones we did. So we did phone by itself, drive mode, and Android Auto. There are others out there. Maybe some are better than others. It'd be interesting to see. Also, another thing we would test is using voice only to control phone, like Siri or Google Assistant. We think those would be safest, probably because you aren't taking your eyes off the road or your hands off the wheel to do anything. It might take longer to do things sometimes, but probably be safer overall. So it'd be interesting to see if we could prove that with a study. Um, Another thing we do different is the simulator we were using. It was a racing simulator. We were on a track, a circular track. We gave a speed limit, but otherwise you didn't have to stay in a lane. You didn't have to stop for stoplights. Didn't have to worry about other cars or pedestrians. So I think we might try and find a driving simulator for cheaper, that could maybe do pedestrians, other cars, traffic, traffic laws, like obstacles, and I think that would be more representative of driving, at least in town, versus maybe on a highway, where you maybe need to be more alert in a town, where people might be running into the road or other cars might be swerving or doing whatever. We think that could have been better. And then I think adding a few more rounds of participants could help increase our accuracy of our statistics. We didn't get a huge amount of participants, but we only held the study for one day and collected data for one day. So probably be better to hold multiple days and try and get more and more participants throughout those days. It's just, for this project, scheduling is hard to have everyone meet up, and so maybe we would try and get more days in to gather data for this project. So and finally, our conclusion was that there's not a huge difference between these apps or using your phone, from our results. And I guess what we can pull from that is distracted driving is distracted driving, and no matter when you're using your phone, if you're taking your eyes off the road to use your phone or your hands off the wheel to use it, it's just not as safe as just driving normally. Part of it could be that people weren't as used to the driving apps as they were just using their phone by itself, which could affect maybe the time it takes them to do things. But from our results, there's no difference, not enough of a difference to warrant using an app over just using your phone. But yeah, we found that the driving apps didn't help at all. And then from that, we learned that phones should just not be used. People are, when they're distracted, and it could cause an accident or whatever. So when using phone, people might want to use voice commands only, because your eyes stay on the road and hands stay on the wheel. That we conclude that it's just not safe to use a phone while driving, regardless of the interface.